Lecture 6.4, Lensmaker equation. This equation calculates the focal length of a lens. Now, we've talked about some details about lenses here, and again, we have to look at the middle. So when I look at these lenses right here, these are thicker in the middle. So if you make a calculation and it's not positive, then it's not a converging lens that you calculated. You have to make sure that you pay attention. So this immediately tells us here that the focal length better be positive. On the other hand, these two over here, these are thinner in the middle, which means that it's diverging. So if you know you have a diverging lens and you do the calculation, that focal length better be negative. Now this guy here in the middle, I can't tell. So in this one, I have a question mark as to what is going on. So let's go look at the equation here. The lens maker's equation is a relationship between the focal length the index of refraction and the radii of curvature. Of the lenses maybe you should say of a lens two curved surfaces. So it reads 1 over the focal length. Then you could see I have n minus 1. So right away, what you're seeing here is that we're making some assumptions here. This guy right here is the index of the lens. The 1 here assumes that we're talking about air. That's where the index of 1 is coming from. And then it has two radii. So it has R1 minus R2. So now what you're seeing here is that you're seeing this. This here is the radii of curvature of the first surface. that light interacts with. Therefore, this guy right here, this is the second surface that light interacts with. So what we want to do here is that I want to draw one lens, and then let's look at just a couple of surfaces here, and it goes like this. So what I'm going to do here is that I'm going to draw a lens surface that looks like this, and then maybe I have a lens surface that looks like that. So you can see that this lens is not symmetric, and that was done on purpose. So what I'm going to do here is that, of course, this is the, so if I look at the first surface that light interacts with, I'm going to say that this first surface looks something like this. You could see that this curvature is following something like this. So somewhere on this side, right, on the right side over here, this guy belongs to the blue curve right in here. The blue surface, the blue one right there. And so what we do here is that this tells us that this guy right here, that this is the first surface that the light interacts with. So therefore, this is what we call the positive curvature. Could we have picked it the other way? Yeah, but this is what's customary. And that gives us the positive R value. So in this case, this is going to be positive R1 because it's the first surface. Now the second one here, you could see here is that this radius is actually smaller. So when I go and I look at here, this region then is going to tell me in this situation that this is the second surface. So what I'm saying here is that this guy right here, this is the second surface. So that means here is that on this left side, this is known as the negative curvature. I'm gonna run out of space here. So this is gonna be the negative curvature. And so therefore, in this case, R2 is negative. So this makes sense here. So the reason why this makes sense is that let's apply the lens-maker equation to the situation. So if I look at this, we immediately see that it's thicker in the middle. So that implies it has to be converging. But converging means it has a positive focal length. So if I look at this particular lens, it's in here that's important. Look at R1. R1 is positive R1. And then I automatically have a minus, but look at the curvature of R2. It's negative, but there's already a negative here. So then I'm going to have negative R2. And what you're seeing here is that I have a negative and a negative that cancel out. So I'm going to get n minus 1 and then this quantity, which is R1, and then I'm going to have R2, and you can see here is that that is a positive quantity, so it's going to be positive. So the Lensmaker equation agrees. So now we're going to move on to example 6.1, where we could practice this over numerous lenses. I believe there's 6 of them.